Hello, friends. Welcome to the Your Project Shepherd podcast. I'm your host, Curtis Lawson, and we are here to teach that every successful construction project has 4 components demonstrated by this simple drawing of a house. The foundation is proper planning. The left wall is your team, the right wall is communication, and the roof is proper execution. Have all 4 of these components in place and your project will succeed. We're here to help professionals and homeowners alike make the best decisions about designing, planning, and building custom homes. If you'd like more information about how Shepherd can help you with your project or business, visit us at yourprojectshepherd.com. And now, here's today's episode. Hey friends, welcome to a new episode of the Your Project Shepherd podcast. I'm your host, Curtis Lawson. And I am joined today by, and I'm going to get your last name correct, I hope, Voya Milasonovic.
Very, very good, yes. And that actually, for those of you listening, he actually did try to say it a couple of times, but only twice before. So this is impressive.
I'm a natural Yugoslavian. Serbian.
Well, either way, yeah, both works.
So Voya and I met a while back at some industry events and trainings. I see him around those things all the time. He is a self-proclaimed building science geek. He's an expert on HVAC issues and electrification. I invited him today to talk about HVAC technology, kind of what's new, what he sees coming down the road in the future and over the next few years. And I kind of wanted to start off by, just because I think a lot of builders like me, or like I maybe used to be and still am to some degree, a lot of us, we're glorified schedulers, and most of us maybe have worked in some of the construction trades like carpentry and framing and things like that. But HVAC is kind of like this own little world that I think a lot of us, while we know the basics and we go to building science classes and we learn what we can, it's still kind of its own little world. It's its own little mystery to a lot of us, right? So I really wanted to kind of start today by just baselining like some terminology. What's your take on that, on kind of HVAC being its own little world for builders that a lot of us are ignorant in? What are your thoughts?
Yeah, it very much so is, and I'll take it a step further. I'll say that it's not just the builders that are necessarily ignorant of it, because it's the out of sight, out of mind, right? Do you see your HVAC every single day when you walk through the door? No, you don't. You see your cabinets, you see your granite countertops. Those have to look pretty.
Yep.
You don't see the HVAC. So it's an industry and it's kind of its own little world that even the contractors who install HVAC a lot of times can be somewhat ignorant of. And it's really with the technology itself, right? So heat pumps are the big buzzword right now in the media and everywhere else. Everyone wants to go heat pumps. Are they new? No, heat pumps are not new. Heat pumps have been around for decades now. But what's important to understand is that the heat pumps of today and heat pumps of 10 years ago, 20 years ago, are a completely different animal. So that's something we can kind of talk about a little bit more and explore.
I actually remember when I was a kid, when I was 10 years old, my family moved from Houston to North Carolina. And, here in Houston in the 1970s, 1980s, all we had were, gas furnaces. And I moved to North Carolina, and my parents said something about our house has a heat pump. And, being 10 years old, I didn't know what that meant. But I heard that terminology a lot in North Carolina in the 1980s. And I think that other parts of the country have maybe been faster to adopt some of that technology than Texas. But I do recall back then that people were always kind of complaining about their heat pumps, having problems with their heat pumps. And man, I wish I just bought that gas furnace. I think the technology over the last 45 years since that was, right, that technology has come a long, long way.
Oh, God, yes. I mean, 20 years ago or even 10 years ago, a heat pump, at 40 degrees, you basically can kiss your heat pump goodbye. So anything below 40 degrees Fahrenheit, it still produced a little bit, but not enough to make it count. So you still needed that backup electric heat strip, which drains your electric account, right?
Oh, yeah.
So not only that, but when they go into defrost mode, they would have to shut off and switch into cooling mode, and you'd have to run your electric heat heat strips so that the heat pump outside can steam and look like it caught on fire while it's trying to defrost, right? So there's a lot of things that just really didn't work very well. Today's heat pump technology, especially technology from the large manufacturers, like Mitsubishi, LG, Daikin, Samsung, Panasonic, they are making technology, heat pump technology, that is capable of producing heat straight from the heat pump without any kind of backup, down to like negative 13.
Wow.
And, some stuff is being tested right now that's going even lower than that. So we're talking about now a heat pump that can genuinely take care of a home in Vermont, in New York, right? I mean, I drive through Canada. Most of my family's up there, and I drive through QEW, and I'm looking at this skyscraper, and all I see is heat pumps all along the side of the building, on every balcony. We're in Canada.
Yeah.
Right? You wouldn't think that a heat pump can handle that, but absolutely, with the new technology, they absolutely can.
Yeah, we switched a couple of years ago on Toner's urging. We switched all of our projects to heat pumps here in Houston. Mainly because we are making a push toward electrification, which is something we'll talk about some more. Our clients have not had issues with them and love them. So I think it's the way of the future.
Yeah, absolutely. I mean, the E word. It's kind of, in some circles, it can kind of be of a bad word, right? But really, when I think about it from my perspective, I hunt, I fish, right? That is something that I absolutely love to do. It's my pastime. I want my kids to be able to do so as well. So as a hunter and a fisherman, I've looked at other people that I talk to and people that enjoy those activities as well. We are huge into conservation, right? I mean, I donate every year to the Coastal Conservation Society here. It's like, I want to be able to continue to do these things. So electrification for me becomes literally about that. It becomes about conservation of the environment, not so that I can save the planet and hug a tree or two. It really becomes about having that ability to enjoy this environment and to enjoy the things that I enjoy doing with my kids much, much longer, and for them and their kids to be able to enjoy it too. So it really all kind of ties together and comes together in a big circle.
Yeah, I wish you had been at the GHBA event last week. We had Gord Cook was in there doing a presentation, and there were a couple pretty heated discussions among people in the room. So the whole presentation had to do with building envelope and all that kind of stuff, which was, no debate there, right? But then the last phase of his presentation got into electrification and carbon capture and all that. And man, the mood in the room changed.
It shifts really, really quickly.
And there were arguments about, as you would expect here in Houston, Texas, there were arguments about, that's greeny weeny stuff and blah, blah, blah. I wish you had been there, because the point that you just made, I think, is what all the hunters and fishers in the room, all the redneck builders in the room, that's kind of the mentality that I think they need to be taking. And it's a tough sell, especially when they're all kind of ganging up on poor Gord up there.
It is really a tough sell, but it can be explained in a honest and transparent way, because we all want the same thing. It's just, how do we approach it, right?
Right.
And I love Gord Cook, by the way. Gord Cook is a great guy. He is extremely smart, extremely knowledgeable. I will say that, having the ability to have Gord there at the HBA event is a huge bonus to those builders, right? Everybody that was in that room got a little bit smarter that day.
It was sold out.
Yeah, Gord is an outstanding educator. I've worked with Gord for quite a number of years now. Sam Rashkin is another one that I would say is really an evangelist for this. But from the perspective of a builder, it's about creating something that is more sustainable, that people actually want to pay for, right? If we sit down and we look at NAHB's polling data, every single poll that NAHB has put out and put data out for the last 5-6 years says that consumers today, because let's face it, millennials are our biggest buying block right now. Consumers today are absolutely willing to pay more money to have a home that is healthier, more efficient, and more connected. That is what they want. And as builders, that is what we need to deliver, or we go bye-bye, right? So it's really what they're trying to promote is not electrification for sake of electrification. It's electrification for sake of helping our grid. I mean, did you know that 63% of Texas households, whenever it gets a little cold, still heat with electric heat strips?
Yeah.
Where do you think the demand goes? Why do you think we had the big snowmageddon of 2020? Was it 2020 or 2021? 2020, right?
Yeah, 2021, I think. Anyway, yeah.
Either way, I mean, it happened because there was such a huge demand on the electric grid from the inefficient pieces.
Mm-hmm.
But we also didn't have enough gas pressure to supply the generators.
Right.
So electrification has to be beneficial. And it has to be done for the right reasons, which is to save the consumer money, to save the builder money. If everybody saves money and it increases comfort, now it's beneficial.
Yeah.
But if I just do it for the sake of electrification, that's not beneficial, man. That's politics.
Yeah.
And we're not in the business of politics. We're in the business of trying to make money, right?
And also a lot of the electrification conversation has to do with indoor air quality as well, because you start talking about how we're, by code, we have to build the houses tighter now. Having an open flame, having combustion happening inside a tight envelope is just not a good idea. And we try to ventilate to overcome that problem, right? But really, in fact, one of the conversations I had with Ken Nelson from Panasonic last week, and one of the things we talked about with Gord in that class was that gas combustion is one of the biggest sources of asthma issues. For children, adults, everyone. And so when you get this tight house and you've got the 48-inch gas range or you got the gas fireplace, man, that's a bad situation for somebody with asthma.
Oh, absolutely. And I mean, not just asthma. I mean, it's all other allergens. It's
Sure.
A lot of different things, including fatigue, headaches. A lot of those things in homes can be traced right back to air quality.
Yeah.
So when it comes to the HVAC side of things, right, we tend to think of HVAC as air conditioning.
Right. Especially here.
Yeah, but what happened to the V
right.
in HVAC, right? The ventilation component. How do you want to ventilate? Well, you don't want ventilation to come through your nasty walls and God knows what's left inside there after it was built.
Sucking all the roach poop and mold into your air, yeah.
And everything else. So it's like, yes, it is key to seal the envelope properly and then control where the air comes from.
Right.
And that's all about ventilation. And then you marry that with your HVAC system. And in Texas, if you're a builder in Texas and you're not putting in dehumidification, supplemental dehumidification, I mean, look, let's just say Toner doesn't do just one thing, right? Toner is an extremely, extremely smart guy, and he will be the first one to always say, dehumidify, 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 because we live in an environment. We don't live somewhere where you don't have to chew your air to breathe it. Like I joke with people, when I came to the U.S., I was a 17-year-old kid who came to the United States from overseas. I had never seen a forced air furnace or a forced air anything in my entire life. We don't have those things where I'm from.
Yeah.
All of our air conditioning and heating and things like that is done without ducts. So, and that's by necessity just because of how we build over there. And I come to this country and I'm looking at it and I'm living in New York for the first 10 years. And then I moved to Texas. And I tell people it took me 5 years to learn. I had to chew the air first before I could breathe it. It is oppressively humid here. If we bring that air into the house, what do you think happens inside the house? And especially when we have a tight envelope, that humidity has nowhere to go. The humidity we generate from cooking, from showering, from just talking has nowhere to go.
Yeah.
That's why a lot of people have comfort issues. And then you start having mold issues, mildew issues, things like that. So it's like HVAC has to be looked at as a whole system, and it has to be applied as such.
Yeah.
Just throwing pieces in never works.
I almost feel like the letters should be rearranged and the V should be at the beginning, because honestly, the ventilation portion of that is probably the most important piece of it.
I would agree with that. Absolutely.
Let's change it to VHAC.
Let's add envelope to it too as well if we can, because envelope, without a good envelope, none of this is going to work. So.
Exactly. Well, hey, we kind of got way ahead of the direction that I was hoping to go, which is perfectly fine. I kind of said, hey, let's start off by defining some terms. So, but that's cool. So let's just back up to like HVAC explanation 101. I wanted to kind of talk about like what is in terminology, what's a traditional air conditioning system, which we call a split system? Mm-hmm. What's the difference between that and a mini split? And what's the difference between that and a mini split, like a VRF system? They're getting popular. There's a few manufacturers that produce that now. So just give us the quick and dirty explanation of what's a split system, what's a mini split system, what's a VRF system.
All right, so let's talk on the air conditioning side, right? We'll leave the H and the V aside for us. So air conditioning side, what we have is you're going to have a typical split system, which is going to have an air handler or a furnace on the inside. So let's just take that as basically it's just a fan. That's all it is. It just moves air across a coil. That coil gets either heated or cooled. In the air conditioning side of things, it gets cooled by the compressor that sits outside your house. And all it does is it compresses the refrigerant in such a way so that as it passes across that coil, as it expands, it has the ability to absorb heat, right? All we're doing is we're not cooling the air. We're simply removing heat from the air. That's all we're doing. And we're taking that heat through the refrigerant, piping it outside, and then dumping it outside where we don't care if the hot air goes to, right?
Right.
That's what air conditioning is. That is a simple explanation. So traditional HVAC systems, traditional AC systems, it's a compressor that just simply kicks on or off. So liken it to, let's say, your car. And you're sitting in your car, you don't have a gas pedal. There is no gas pedal. Gas is always on and it's always pushed all the way down to the floor, right? Yep. It's stuck. So you come in, your car's already in drive. You just click the engine on, and as the engine hits real hard, car takes off like a bat, right? And let's say you want to maintain 65 degrees on the highway or 65 miles an hour on the highway. You're going to let that car run until it hits about 75. You're going to turn the engine off and let it coast until it goes to about 50. You're going to turn the engine back on, and you're going to keep doing that on and off, and just to maintain that comfort level, that speed you want to go. That's a traditional HVAC system. Now we go into mini splits.
And sorry, the terminology comes from split system means one unit's outside, one unit's inside. They're split into two pieces.
Exactly. Exactly. If it wasn't split, it'd be basically
a package unit.
Well, package unit, or let's even go worse. Let's go just a window unit.
Yeah.
Right?
Yeah.
I mean, that's a package system.
Right.
So split system, like you said, fan inside, compressor outside.
Yep.
That's it. A mini split, literally just like the name says, it's the same kind of system. It's just smaller, right? Our typical unitary systems start at 1.5 tons in size, and then they go up to 5 tons on the residential side, and you can go much, much bigger than that on a commercial three-phase side.
Yeah, and a ton's not what it weighs. A ton is 12,500 BTUs, which
12,000 BTUs, yeah.
Arbitrary unit of measurement, which it's a whole other story. But
yeah, British thermal units, right? Yeah. It's how much energy it takes to melt a pound of ice.
How many British people does it take to push a block of ice up a hill?
Exactly.
Yeah.
So
I think that's what it is.
Yeah, it's something like that. I agree with that. Now on the mini split side, you can have split systems that go down as low as 0.5 ton. So why is that important? As we build buildings tighter, as we add more insulation, basically what we're doing is we're taking the old, igloo cooler that my dad had sitting in the garage, and I'm converting it to a Yeti. That's what I'm doing. I'm making my home much, much more efficient at holding the inside temperature. It's tighter, it's better insulated. The money that I spent to cool that air stays cold inside my home a lot longer than it would have in a house built in the 70s. That's really what it is. But because the house is now tighter, more efficient, and better able to hold the temperature, I don't need a 4 ton, or I don't even need a 1.5 ton system anymore. I need a 0.5 ton system or a 3/4 ton system, right? That's where mini split comes in. Mm-hmm. VRF, variable refrigerant flow. That's really all it is. Take that car that we were just driving a minute ago, and we didn't have a gas pedal, and we didn't have drive, we just had on and off, give it a gear shift, or actually even better, make it a standard. Give it a speed selector, right? And then give it a gas pedal. Now we have the ability to speed up and slow down. We can run our engine, but by speeding up and slowing down, it's much smoother. It's much easier on the engine. It's much more fuel efficient, and it's just more comfortable. And I can maintain speed that is much, much better than just constantly turning it on and off.
And you could go all the way from 5 miles an hour, right?
Absolutely.
Up to as fast as you need to go. Whereas the old systems were like, as you said, you're going 65 or you're going 0, right?
Absolutely.
And sometimes you need to go 5 or 10.
Absolutely. And on the high side, obviously we're never going faster than speed limit, right?
Right.
But we have that option if we need to. So mini split and VRF truly is the same technology at this day and age. All mini splits have the ability today to speed up and slow down.
Right.
The larger VRF systems just simply have the ability to slow down to a much lesser percentage of their total capacity. And then they have the ability also to speed up a little bit past 100%, just to give you that short little burst of that capacity you need when you come home from a cruise and it's 85 degrees inside your house. You want to get it down to 72 a little bit quicker, right? That's really all the difference between a traditional system and a mini split and a VRF.
So on the heating side, I'll back up a little bit. So I guess on mini splits, the technology is there to have, on certain systems, to have multiple, call them head units inside the residence, right? Driven off of one compressor on the outside. Am I explaining that correctly? So you could have your single outdoor unit, and then in your bedroom you could have one head unit in the ceiling, one cassette in the ceiling, and then the other room you could have another cassette in the ceiling, each kind of doing their own thing, right?
Yeah, so now we're getting into the multi-split, right?
Yeah.
Or a multi-zone, or whatever we want to call it. But in essence, what it is just like you said, when you have the ability on the outside unit to speed up or slow down your compressor. So in other words, like in our previous example, in a traditional system, it's on or off. So it's all in or all out. In a VRF system or a mini split system, because we can speed up and slow down the compressor, we're speeding up or slowing down or actually changing the amount of refrigerant we can deliver inside. That now gives us the ability to split the indoor units, because instead of zoning through zone dampers, which is what most builders and homeowners are know and used to,
right,
which is just shifting where the air flows. Really I liken it to kind of trying to fit, 5 pounds of stuff into, or 10 pounds of stuff into a 5-pound bag. We're still producing the same amount of air. We're just shifting where it goes. With a VRF system, we now produce a different amount of refrigerant depending on what the inside needs. Depending on time of day, depending on how hot it is outside, depending on what rooms we want to use, all of those different things. So now I have the ability to put in, like you said, either a wall-mounted unit or a ceiling cassette or a ducted system, like a traditional ducted system that I can put to cover my common area. So let's say I'm going to have a ducted system, and this is like my personal preference of how to zone these things out. I can have a ducted system that covers my kitchen, my dining room, my living room, all my common areas, game room, things like that. Then the kids' bedrooms can have their own head, their own ducted system, right? And then my primary suite can have its own ducted system. So what's the benefit of that? Well, because my outside unit can slow down and speed up as it needs to, it's only using the amount of energy that it needs to use for that moment. So let's say my kids like to sleep at 72 degrees. Great. Let's say I like to sleep at 67 degrees. Great, right? I can do that now. In the common area, which is 3/4 of my house, I don't have to cool that. I can just set that back to 76, 77 degrees, and I can save a ton of money at night while delivering air exactly where I need it, where I'm occupying. So it saves me money, it increases my comfort, and it's just a better way to live.
Yeah. And don't some of the VRF systems have the ability to heat one zone and cool another at the same time?
Yes. So there are a couple of manufacturers on the residential side that do have product capable of simultaneous heating and cooling. On a commercial side, it's much more prevalent. So for those folks that do build in the commercial environment, it is an extremely efficient way to build and to heat and cool a space. Because what happens, we talked earlier, right? What is air conditioning? Literally in the cooling side of things, we're not adding coolness to a room. That's physically impossible. We're removing heat. So what do we do with that heat? We reject that outside to the compressor. But if the room next door needs some heat, why wouldn't I just take that wasted heat, give it to that room? It's going to heat up. Oh, but now I get an unintended consequence, kind of, sort of that hot refrigerant now got pre-cooled because I dumped a lot of that heat into the room. So now when that goes to the compressor, my compressor doesn't have to work as hard as it would have otherwise. So now I'm just reusing. It's recycling energy, which is amazing.
That's what I should put in my house, because my wife always wants her office warmer and I want my area cooler. So
you can do that, or hey, mini split, right? You can put a mini split on it and she can control heating or cooling however she wants. And that's absolutely fine too. It's just a difference of what fits the budget and what makes sense from a design standpoint.
Aren't the VRFs expandable also? So like you could go in and add another system to an existing compressor?
They can be. It has to be done with caution, right? So we want to make sure that we're sizing our system, our totality of the system or the compressor itself. We have to size it appropriately. So if you know that you're building out this home and you have a bonus room you're going to finish, and you want that bonus room on its own separate indoor head, right? That's fine. But you just haven't quite finished it when you're moving in. You know you're going to make that happen.
Or you want to do it 2 years from now when the budget allows?
When the budget allows, 2 years from now, just make sure that the system you have sized for now falls kind of within that happy spot between minimum capacity, maximum capacity of the system, and also your 80% load and your 1% load, right? And when we talk about 1% and 0.4% sizing, it's kind of one of those crazy things where we have to be careful when we do that here in Texas, especially in Houston, because of the humidity we have. We don't want to oversize our AC system. It is much better for your AC system to run longer and help remove more humidity out of the air than to have a system that's sized for 105 degrees when realistically we hit 105 degrees maybe every couple of years. And even then, it's only for a few hours in a year. So if we're sized for 105, what happens the rest of the year? We're grossly oversized.
Especially when it's a traditional system, split system with one speed on or off. Yeah.
It's actually even worse with more efficient multi-speed systems, because the lower we drop in speed, the less latent capacity we have, which is capacity to remove moisture out of the air. So that's where sizing the system right, and then also incorporating ventilation and dehumidification is so important to make sure we have a healthy indoor environment for the consumer, because that's really the key, right? Air conditioning is comfort. Ventilation is comfort. But it all, dehumidification, comfort, it's all part of health as well.
What before we get off the VRF topic, what are the drawbacks to using VRF? I mean, I would assume that right now in today's market, just upfront cost of those systems is more. Is that a fair statement?
No, actually, I will say no. So in today's market, over the last, I would say 8, more recently 5 years, the cost of typical products has caught up with the cost of the mini split and multi-split systems. So really realistically, comparing apples to apples, a equivalent 18 or 21 SEER multi-speed system or a couple speed system, let's say a 2-stage system, from a unitary product line and a variable speed system with about the same SEER rating at the high speeds, right? From a mini split or a VRF manufacturer, the cost of equipment is pretty close. So I would say that it can be done right now. Like when I built my house 4 years ago now, when I built the house, the difference, the delta between putting in a really, really good manufacturer's 2-stage heat pump system in the house with backup electric heat strips, and that's it, versus the system that I put in, which had 5 ducted indoor air handlers and 1 outdoor VRF heat pump without any kind of backup heat or heat strips needed, right? So using less electricity and less capacity on my panel, but also adding a dehumidifier. That entire delta was less than 15%.
Wow.
That savings right there for me paid off within the first 10 months of owning the home.
I'm sure, yeah.
After that, I'm saving money. I mean, a 4,000 square foot home with pretty much the entire south wall glass with a big pool on a well system and a septic system, and my electric bills in summer are less than $250. That's pretty darn good, right? But I didn't achieve those $250 bills by not setting my thermostat low or keeping it at 78. No, that house was kept at like 72 degrees all day long, 67, like I said, at night,
right,
with 45 to 50% humidity inside the house. So it can be done. We just have to look at it from a holistic perspective and apply the entirety of the HVAC altogether.
As a builder, I often price new construction projects out multiple ways. So I'll price it with a traditional split system, a heat pump system. I'll price it with mini split systems. And oftentimes the cost to do the mini split VRF route is a lot more expensive on paper. I'm just wondering do you think that maybe some of that cost is driven by the installers and their unfamiliarity with the system and kind of their kind of worries of it's going to be more of a pain in the butt for me, or I don't understand it, so I have to charge more? Do you think that's the case?
It's fear of change. Absolutely. I know what I know, and I know how to price it. Mm-hmm. Ooh, this looks a little bit different. Let me just make sure that I'm covered. There's a big cost difference between those two. So what we have to do better as an industry, as manufacturers, is we have to do a better job of training installers, not just technicians, but installers. We have to do a better job of making sure that they are comfortable with installing these products. Because let's face it, this is the way the technology is moving. This is the way the world's moving. It's not an if, it's simply a when, mm-hmm. right? We live in Texas. We don't like change. We love the way that things are, and that's what makes this state beautiful. That's what makes this state my home. I love the pride that we have in our culture and how we do things. We still are going to shift to this technology, and we already are. I can see this now. When I was working in direct sales to contractors, of selling this type of product to contractors before my current role, my biggest customers were the guys out in the boonies, because they understood we have a very limited size grid. We want to give the consumer the comfort level that they want. How do we do it? So they've already started implementing this technology across the board. Everything is shifting this way. We just have to make sure we catch up the installers so that they're comfortable. They're not pricing these systems more expensive just so that they can make more money. They're not doing it out of any kind of spite. Yeah. They're simply doing it because they are not as comfortable with that as what they are with the same things that they've been doing for the last 20 years, right?
As far as a drawback goes, is just kind of general contractor knowledge of the systems, whether that's installation, service, whatever. I would put that under the category of kind of a current drawback, although it's not really a drawback, but it's a barrier to implementation, is contractor knowledge.
Yeah, and I wouldn't say it's a drawback. I would say it's an opportunity. It's an opportunity for the builder to build a better relationship with their manufacturer, because manufacturers will provide you resources and training. They will help you navigate this path of transition, right?
Yep.
So it's an opportunity to build that relationship with the manufacturer. It's an opportunity to build a better relationship with your contractor and with the distribution partner, with the entire support team, which now gives you as the builder far, far better control of what goes into your homes, how well it works, and how many callbacks is it going to eliminate down the road, right? Because as builders, we can look at, well, here's our first cost, but how often do we think, how often is that first cost being lower? costing us on the back end from callbacks and issues, right? So it gives us an opportunity to just tighten up and have better control over what we put in our homes.
Yep. What do you think is coming down the road over the next few years? What's the future of the HVAC or VHAC industry? Where do you see things moving?
So things have already steadily been moving towards the implementation of VRF technology. And what I see coming down the pipe are more heat pump systems that are capable of heating and cooling at lower temperatures and higher temperatures as well. Let's face it. Whether we want to talk about climate change, global warming, whatever the case may be, whether it's man-made or not, I don't care. I'm not into politics. I don't want to guess. I'm not a scientist. I'm a building scientist. What I can say is that last couple of summers, it's been really, really hot.
Yeah.
Last couple of winters, even here in Houston, it's gotten kind of cold. So do I really care whether it's any kind of climate change? Well, when it's 14 degrees outside, I'm not really caring about climate change. What I care about is, can my system keep me nice and warm inside my home? So I see the technology improving and giving us the ability to heat and cool more efficiently at more extreme temperatures. The other part that I see is, especially when it comes to like the northern climates and climates where we really do need some heat, I see systems that are capable of incorporating domestic water heating. So like, the water that you shower with and bathe with and cook with, that heating alongside your space heating and cooling, right? When we use energy to generate cooling, we waste a lot of heat. We throw all that heat energy, we throw it outside.
Yep.
But if we are able to take that heat energy and divert it to heat the water that I need to cook with and shower with, now I'm not wasting that energy. I'm utilizing what's already there, and I'm just utilizing it in a better way, right? It's back to that conservation piece. And it's really not conserving. It is conserving the environment, yeah, but it's also conserving the dollars in my wallet.
Right.
Let's face it. That's the biggest conservation I'm concerned with right now.
That's all I care about.
Exactly. I want to make sure that I can go out and eat tonight. I don't want to spend that money on a water heater. So that's something that's coming down the pipeline. We're also going to see, I believe, and it's already kind of coming slowly, it's going to become more prevalent, this whole ecosystem. Manufacturers are understanding that people today, especially millennials and Gen Z who are now entering into the home buyer market, they want everything to be connected. They want the ability to utilize what they have, their resources, more efficiently. So if I can take my HVAC, which is the biggest electric user in my home by far, and if I can then take my car charger, which is the second biggest electricity user in my home, if I choose to have an EV, and then I take my appliances and my water heater, which are the next biggest electricity users in my home, and if I can stagger them and control them more precisely and have the ability to stagger that electricity draw, not only am I ensuring that the draw on the grid is less, which makes the grid more stable, so it ensures that I'm not going to have as many brownouts or blackouts in extreme conditions, but I'm also putting myself in charge. So as a homeowner, if I electrify all those things, and if I put some solar on my roof and I put a battery pack, just a small one in my garage, do I really care if something happens and a hurricane comes through and power goes out? I don't. I'm still comfortable. But if I can do all of that and control it all and see it all through one interface, I win. So I see that kind of coming down the pipe is manufacturers that have the ability to put the entire ecosystem together, package it, and make it work. That's key. I don't care if you have an app that can control everything if it doesn't really work the way you want it to.
Yeah.
But having all that ecosystem functioning seamlessly, that's the future. That's where we're going.
I think that you already see people trying to do that on their own. You see homeowners trying to kind of put together that kind of thing themselves piecemeal, right? You'll see them, whether it's installing a separate dehumidifier or just getting a portable dehumidifier, air purifier, And then they have all these different devices they're trying to connect on 3 different apps on their phone. They're trying to piecemeal all this stuff already, right?
Yeah, they are.
And so if a manufacturer can provide a solution to that encompasses all this stuff, and we can install that in a home from the beginning when we're building a new home, that's a big advantage to the consumer. It's taking a lot off their plate.
Oh, it's huge. It's taken away from them having to invest more money, right? Because right now, like you said, we build a house, we move into it, and then I, as a consumer, go out and I buy all of these things. I invest money into all of these things, and I piecemeal them together. And typically, to do it well, it costs quite a bit of money, right? But imagine, as a builder, I build a home and I include appliances and all this equipment that already has all of this built in, and it does it. And now I'm not costing my consumer any more money down the road. Guess what I'm providing now? Value.
Yeah. And
a consumer recognizes that value. So why would I pay $20,000 to piecemeal all this stuff together when I can give you, I can give Curtis here an extra $10K on the house and immediately take advantage of everything for half the money?
Yeah.
Right? I'm providing value. And that's key. That is what the consumer today is looking for. They're looking for more for less. They're looking for easier. They're looking for more connected. They are looking for value in everything.
Yeah. I mean, simplicity would be huge. I mean, I think I have like 5 apps on my phone that control different things in just my home.
Oh, absolutely. So do I. I mean, I've got GoSund, I've got my Kumo Cloud, I've got my Ecobee. I mean,
yeah.
You talk about, like you said, I've got my ThinkQ app. I mean, I got 15 different things that I'm trying to control everything.
Just from my house.
Just for inside my house. Yeah.
And I mean, and several of those probably could be combined, but it's just me taking the time to sit down and figure out, okay, which app can I control more things with? And do I get rid of this one brand and buy something else of this brand so I can have more things on one app? And a never-ending battle of trying to shuffle all these items so I can control more of it.
I mean, that's a lot of education that goes into that, right?
Yeah.
That's a lot of time invested to learn something.
And people don't want to do that. I mean,
No.
they'd much rather have a simple solution that a lot of these things can all work together, or that are made to work together from the beginning.
Look, from a homeowner standpoint, I've busted my butt all day today until 5 o'clock, and then I've dealt with Houston traffic for an hour and a half just to go 6 miles. And I just came home right now. Do I really want to do anything other than just kick my feet up, eat something, and relax?
Yeah.
That's what I want to do. I want simplicity. I want ease, and the manufacturer or a builder that can deliver that is a builder that's worth more money to me.
The best, back on the HVAC side, the best systems are the ones that you don't have to think about.
Exactly. It's simplicity.
It's like you shouldn't have to worry about controlling your dehumidifier and what your indoor air quality is and what your temperature is. It should all be one solution.
That's absolutely right. It's all about simplicity, and it's all about utilizing the equipment that's made to do the job, right? Can our existing 20-year-old typical unitary HVAC system, can it remove humidity? Absolutely. Yes, it can.
They're actually very good at removing them as long as they're running.
Good, as long as they're running. And we have figured out a way as manufacturers to use controls to kind of cheat the system to make it do something that it wasn't designed to do, right? They were not designed to maintain humidity levels.
Yeah, that was just a nice byproduct.
It's just a byproduct.
Right.
So can I make it happen? Yes, but now as a consumer, I spend money to buy a 21 SEER system that's doing a really good job keeping my humidity at 50%, but it's no longer a 21 SEER system. It's now operating way, way worse than what it was designed to do, just because I'm asking it to do something it wasn't meant to do, right? But if I incorporate the entirety of the system and I use the right tool for the job, dehumidifier to maintain latent, my AC system to maintain sensible heat, right? That's the heat we can sense. Now that dehumidifier is doing the job that it was specifically designed to do. Now my HVAC system is still 21 SEER, and I'm maintaining humidity for a lot less money a month than I would have been able to do just with the AC system.
Yeah.
So it's thinking about it from a holistic perspective.
I think a lot of manufacturers are working toward that right now. I mean, I know Panasonic is. I think Mitsubishi, Daikin. I think several of these companies that manufacture a lot of these, mini split, dehumidifier, ERV systems, I think a lot of those companies are working towards this goal of what we're talking about.
Oh, absolutely. Absolutely. And I mean, it's by necessity, again, like you said earlier, the codes are rightfully so pushing building to a tighter, more efficient envelope. We have to. The population of this country is growing like crazy. I mean, let's look at Texas. Last year, Texas added over 1 million people to its population.
Half from California, probably.
Well, yeah, exactly. And they all came with money, so you know what they did? They bought big houses. I mean, heck, if I sell a 1950 bungalow in San Francisco for $5.5 million, I can buy me a nice house in Texas for $1 million.
Yeah.
Really nice house, and still leave $4.5 million in my pocket, right? Why do you think our housing pricing is so high? Because there's demand. But that 1 million people that came into Texas, we built housing for them. We added them to our grid, both gas and electric.
But we didn't build new power plants.
We didn't build new power plants. Now, what we did do is we added microgrids, right? We added solar, we added wind, we added storage. Those things currently are being added because they are quick and easy to deploy. They are fairly reliable with storage. They're far, far more reliable. But the crazy thing is, we think about Texas. We're all about gas and oil. Who's the largest producer of renewable energy in the United States right now?
Probably Texas.
Texas.
Yeah.
Yeah. We are second in solar production, only behind California. Very, very, very close second. And we are so far ahead of everyone else in wind production that the next 4 states have to combine their wind production to catch up what Texas produces. So
that's a cool stat.
That's a pretty cool stat when we talk about that 18% of our energy in Texas comes from renewable sources. That's not because we want to save the planet. It's a consequence that's, to me, it's a cherry on the cake, right? Why wouldn't I? If it doesn't cost me any extra, it makes me feel good. But it's because we don't have the infrastructure and we can't possibly build it out fast enough to satisfy all these subdevelopments coming up.
Right.
So we throw some solar, we throw some wind, we throw a battery or two, and all of a sudden now CenterPoint has the ability to deliver power where power is needed.
Yeah. And this is actually something that I've just learned a bunch about over the last few months since I got involved with EBA, which we were both at last year, and became friends with some people who were in the energy, people who work for the utilities rather. Yeah. So as a custom builder in Houston, we don't generally take advantage of all the incentives that are out there. But all the production builders know about this stuff, right? Like the utility companies will pay builders. They'll give them free money for having their houses on these programs. And again, custom builders, none of us ever mess with doing all that stuff, although we probably should. Let's be honest.
You absolutely should. When I built my house, I built a brand new house, custom home as well. I got almost $2,000 back from CenterPoint.
Right.
In rebates directly to me because I utilized a ducted 5-ton, but a mini split technology system. Yeah. There's tons of rebates for that big builders don't take advantage of because they have a different program.
Yeah. Well, they can get, dollars for being on Energy Star. They can get more dollars for having an EV charger, more for being next gen. There's all these programs that they get free money for. I say all that because the whole point of that is CenterPoint, it's cheaper for them to pay the builder $2,500 per house than it is for them to go build a new power plant.
Absolutely.
And so by reducing the demand on the grid, that's a big advantage to them. So again, when we build infill houses in town like we do, we should probably, throw that out there, because if we can make an extra $25,000 a year just in government incentives, that's like free money to us. That's like a big Christmas party for the staff.
Oh, absolutely it is. But then tie it also with a couple of other things. Tie it with the fact that when you're building that infill house, what was the service that was there to begin with? 100?
Yeah,
maybe 200 amp service at best?
Usually 100, 125, yeah.
Yeah, but you're building this really beautiful, amazing 3 and 4 4-story townhome.
400.
400 service.
Yep.
So But think about it this way now. Let's say you utilize a smart panel instead of just a cheap regular panel, right?
Right.
Smart panel might cost you a little bit more, but now the code allows you to size your electric service way differently because you no longer have to apply the same formula.
Right.
Because that smart panel is now your energy management system. And there is a provision in the code that allows for that, right? So you use that panel, and now you use the better, more efficient HVAC system and a water heater. So let's say you use that heat pump, that inverter mini split heat pump, and you use an inverter heat pump water heater.
Yep.
Right? Both of which give you incentives from the utility and incentives from the federal government in the form of tax credits, right? 45L tax credits to a builder.
Yep.
But you've also now saved $5,000 for not having to upgrade to 400 amp service.
Right.
So now you're combining and stacking all of those incentives. Is this costing you more now to go with better technology and make that customer's home more comfortable?
Yeah.
Or is it actually costing you less and it's costing the consumer less? So everyone wins.
Yeah.
It's got to be looked at as a whole ecosystem.
That's where the builders have to have that education.
Yes.
On how to take advantage and use these strategies to their benefits, because again, as I've said, many times on this podcast, a lot of the kind of quote unquote custom builders in Houston, the small companies, they rely on their subcontractors to do most of the actual building of the house. They're kind of glorified schedulers, and they don't take the time to get educated on these topics. They just call the electrician, hey, I've got a 5,000 square foot house. Here's the loads. You do your load calc. What size service do I need? And they just let the electrician tell them the same thing they've always been doing for the last 20 years. But if the builders will take the time to go to those classes, get educated on these topics, they can be saving themselves some money and making some extra money.
Oh, absolutely. Absolutely. And I mean, that's across the entire industry, and take it from someone who was a remodeler for a number of years as well. There was one thing that I never had time for. I never had time to sleep, and I never had time to sit down and educate myself on something different because I was too busy, like you said, scheduling things, putting out fires, trying to make sure, what am I going to do now? My electrical guy was supposed to be here, but he's not because he got laid up at another job. So now I have to reshuffle and reschedule everybody that comes after him. That's a lot of work to do. If we're trying to do that, it's hard for us to go seek education. So as a manufacturer, we should provide that education. We should come more often to the home builders associations and talk about these things, and not do it as a sales pitch, but talk about it from a perspective of, this is a better way for you to save money, to save time, and still provide what your consumer is asking for, right? Technologies like SIPS panels, right? They're not very well understood. I've talked to builders that sat down and said, I'll never build with SIPs. I said, why? He's like, it's costing me like 3 times as much as my lumber package. Yeah, but your lumber package, you still got to add chases to it. You still got to add insulation. You still got to sheet it. You still got to waterproof it and airproof it. You've got to spend weeks erecting it with a much, much larger crew versus a SIPs panel that goes up. That house goes up in a week with like 3 or 4 guys, and insulation's included, vapor barriers included, air barriers included, like everything's included. Why are you looking at just the package, the lumber package? Look at the totality of the project, and look at the fact that you're going to build this house 2 months faster. You just bought yourself 2 months to go build another one, right? So now you expanded and you're able to build more houses, more money, in the same amount of time with the same amount of people that you had before. So you have to look at it as a change. We still today build houses the same way we did back in 1800s. Other than the technology we use to put them together and how tight they are, not much has really changed.
Right.
We have to as an industry shift, because one of the biggest fears that I sat down for breakfast with a senator from a different state, and he was one of the big proponents of the IRA, right? The money that we were just talking about, the incentives for heat pumps and water heaters and things like that. And he said, "Are you excited? How excited are you about this stuff coming out?" And I said, "Well, I'm excited, but I'm also scared." And his answer was, "Why are you scared?" I said, "Well, in 3 years is when we're really going to see this start having a big impact. Who's going to install it?" I said, "What do you mean?" 63% of the current labor force in trades is set to retire in 3 years. Even today, for every one tradesman that we bring in, 4 retire. Who is going to do this work? So we have to change how we build. We have to change the type of equipment we use so that we can accomplish and build these things in a timely manner with less people. Because we're just not going to have those people, man. Young kids, they don't want to go into trades today. And that's one of the things that I try to do kind of outside of my job and outside my work. I look at the fact that even my dad spent years we walk by and there's a plumber out there doing work and he goes, "See, son, that's why you want to go to college, because you don't want to end up like him."
Exactly.
And I didn't know back then. I didn't understand.
Like, "Oh yeah, Dad, you're right."
And yeah, exactly. And now that I'm 43 years old and I've went to college and I'm working a job that I'm working, and I work with contractors all the time, and I look at plumbers and electricians and HVAC guys and I go, "God, Dad, why did I listen to you? I should have done this." These guys have better toys, more toys. They've got leases that they can go hunt on. They've got nice fishing boats. They've got all this stuff. And you know what else? They've got time to go play with that stuff.
Mm-hmm.
And I don't. I got college debt. They don't. They got all of these toys and things. I'm like, we need kids to understand that going into trades can help. It's amazing. You can make a ton of money and be your own boss, right? We've done a really poor job of doing that.
And there's a lot of satisfaction in those jobs too. I mean, not knocking working in the office. I mean, my wife's an engineer, works for a big corporation, but she doesn't produce anything that she can point at it and say, I did that, or yes, I made a difference in those people's lives because I produced that product, or because I helped them create something, right?
Absolutely.
So there's a huge component to me, and that's one of the things that I love about this business that I'm in, is I love being able to drive down the street in a neighborhood and with my kids and say, "I built that one, I remodeled that one, I remodeled that one." It's a great feeling.
But you know what's even better? When your kids are riding their bike down that neighborhood with their friends,
they say, "My dad did that."
Point out and they go, "My dad built that."
Yeah,
dude, that is a sense of pride and accomplishment, and we cannot replace that.
Right.
We as an industry need to do a better job of going back to that, but going back to those values and valuing the work that is being done hands-on in the field. Because, man, without those folks, we have nothing.
Yep. And this is kind of a little bit of a political topic, maybe, but also when as U.S. citizens, if let's say we have fears about immigration coming and taking our jobs, well, there's a reason that's happening, right? Because U.S. citizens, we are not creating those workers ourselves. We're having to bring people in to do those jobs, and so if you're real patriotic, teach or encourage your children to go into the trades, to have those jobs, and that kind of plays to your political beliefs too, of not bringing in undocumented workers to fill the jobs.
No, you're absolutely right. I mean, people would not be flocking to this country if there wasn't an opportunity, a need, and a demand, right? I was not born here. I was born overseas. And I came to this country, I came through New York. I came through the right way, the legal way. And as an immigrant myself, my children are children of immigrants on one side, right? They're first generation American on their dad's side, and they are 10th generation Texan on their mom's side. Yeah. Their mom is a daughter of the Republic, man. Yeah. She is a 9th generation Texan. So it's like they have this beautiful kind of like a mix of first generation and learning the culture from me and my side of the family, and then 10th generation Texan. I mean, that's pride right there, right?
Heck yeah.
That they have from their mom's side. So this country is the beautiful country that it is because it is a melting pot of cultures.
Absolutely.
It's a melting pot of ideas. But back to your point, because there is a need for it, right? That's what built this country. That's who built this country. Whatever political spectrum I fall on or you fall on, one thing that we all can agree is we all want a better life. We all want a better life for our families. Our building industry is one of the biggest drivers of what kind of quality of life we have. I always used to jokingly say as a building science guy, if you want to experience the worst absolute quality of environment and the best absolute quality of environment, go to a casino. Go to a casino, get a hotel room at the casino and stay there. You're going to go to that room and they've got a nasty, old, loud, obnoxious, and extremely inefficient and humid PTAC or something like that, where you're not comfortable in that room. But then you go to the casino floor and, oh my God, it's like a breath of fresh air. Why? Because they figured out they don't want you in your room. They don't want you on the casino floor spending money, right? But if they can figure that out, so can we as builders. We can build a better quality home that lasts longer, that our kids are able to inherit from us and live in a community and build a community that feels pride, that feels ownership, and that lives healthier inside a home. And all of this can be accomplished without politicizing, without worrying about, oh my God, are we going left or are we going right? Where are we going? It's about, like I said before, I want my kids to fish. I want my kids to hunt, right? Why do I teach my son and my daughter, don't shoot the doe? Don't shoot the young buck, shoot the old buck. Why? Right. Because I want the doe and the buck to have Bambi. I want Bambi to grow up and be an old buck.
Right.
Let's not shoot Bambi's mom quite yet. Let's wait for a while. It's delayed gratification in a society that has increasingly become instant gratification. That's why we like our furnaces, right? Yep. I want to feel that heat. I want it to go from 65 degrees to 80 degrees in 5 minutes.
Right.
And even that's not fast enough. Why not? Chill out. Just be more comfortable. Enjoy it. You're still going to be comfortable with a heat pump. It's just not going to get you from 60 degrees to 80 degrees in 5 minutes. It might take an hour.
Right.
But it's going to do it much, much more efficiently. And when it does, it's going to stay a lot more stable. So it's really just how we shift our perceptions.
Yeah. Well, we've covered a lot of different topics. We kind of weaved in and out there, but I think we had some great conversation. So I really appreciate you being on the show today, Voya.
Thank you, Curtis, and thank you for inviting me, man. And I really appreciate this, and I love this conversation. I want to see more of these types of conversations going on in the industry, again, because it's the direction we're going. It's the direction we have to go. The faster we adapt to it, the better off we're all going to be.
Agreed. And thank you all for joining us today on the Your Project Shepherd podcast. We will see you next time. Take care.
Thank you.
If you found us helpful and enjoyed listening, please support us by liking and subscribing here on your podcast platform, and also join us on our YouTube channel. We want to continue to bring you high-quality content and expert guests, and your support truly helps us to continue this journey. If you have any questions for me or my guests, or any feedback for us, you can email us at podcast@yourprojectshepherd.com. Thanks again.